Sometimes creating an ad campaign can feel like you're talking on mute.
Sorry, we can't hear you. Say that again?
But advertising on Spotify can help your business turn up the volume. With our easy-to-use ads manager, you can create new audio ads from scratch or repurpose existing video assets. Then we'll deliver your ad to an engaged audience that is ready to hear and see your message. It's that simple. Learn how Spotify can add more to your mix at ads.spotify.com. Sometimes creating an ad campaign can feel like you're talking on mute.
Sorry, we can't hear you. Say that again?
But advertising on Spotify can help your business turn up the volume. With our easy-to-use ads manager, you can create new audio ads from scratch or repurpose existing video assets. Then we'll deliver your ad to an engaged audience that is ready to hear and see your message. It's that simple. Learn how Spotify can add more to your mix at ads.spotify.com.
It's the calm before the storm. Things aren't as they were before. You best start bracing. Did you think you could keep us out? Shut the gates, forget us now. The tides are changing. Can you hear the sound? Can't stop us now. We're not back in town, know what we're doing. Things are about to change, it's evolution. Voices shake the ground, you feel it moving. We're the revolution. Can you hear the sound? We're the revolution. We're the ground beneath your feet. We're the whisper in the trees. Do you feel us watching? Hunger in our eyes, victory's on our minds. It's our time to rise. Can you hear the
Hello there.
Can't stop us now. We're not back in town, know what we're doing. Things are about to change, it's evolution. Voices shake the ground, you feel it moving. We're the revolution. Can you hear the sound? We're the We're not back in town, know what we're doing. Things are about to change, it's evolution. Voices shake the ground, you feel it moving. We're the revolution.
Good evening and welcome everybody. It's Obi-Wan Pez for Simplex Pachinko. Thank you so much, Famastra, for something like that. This does not want to stay in the correct location. Okay. That. Yep. So thank you for keeping us healthier? Question mark. Right, good times. So tonight we're going to be looking at some of the some more of the articles that are in the Journal for Mathematics Education, put out by Springer, and maybe we'll take a look at some other things if we have time, but kind of also depends on what everybody wants. And if anyone has any particular questions on mathematics, want to do any problems out, let me know, and we can work on that. Hang on. Hand slipped. I also have not submitted my trivia for the day, so we need to actually do that, because I forgot it was a Monday, because my kids didn't go to school. Everything is messed up because, you know, kids are still in the house. All the expectations have gone out the window. That's a tip, by the way. Definitely. Yeah. Yep. 100%. Blame the kids. All right. Good times. So how's everybody doing? Right. This stuff is still from the lemmas that we were talking about for Exponential Idle. That's a fun one, and I did enjoy doing some coding again. So we may end up doing that again at some point in the future. Let's see. For now, change this over. Hadn't seen that one. Digital literacy. Oh, that's arXiv. Okay. The other one. Elementary Proof of a Minimax Theorem by Jeff Calder from University of Minnesota School of Mathematics, 25th November. Here we give a self-contained and elementary proof of a minimax theorem due to fan 1 in a simplified setting that can be taught in an advanced undergraduate course. Proof follows 2 with some simplifications. Right, K-Fan, Minimax Theorems, Proceedings of National Academy of Sciences, 1953. And Nikaido on Method of Proof for Minimax Theorem, Proceedings of American Mathematical Society, 1959. Okay. Let x and y be subsets of respective real d dimension and real k dimension. And function x cross y go to real. Okay, so we have a function that has a pair of inputs, x and y, individual x and y. So here we're saying that lowercase x and y, which could in theory be, which can be vectors, are going to be individual items within capital X and Y, the sets. Okay, so Minimax theorems give conditions under which it holds that the supremum of the infimum of f of x, y, where our supremum is taken as x belonging to x, infimum as y taken in y, is equal to the infimum. Okay, so infimum and supremum are going to be taken on opposite sets, right? So as long as you're taking the infimum of set y and the supremum of set x, it doesn't matter what order you do them in, you're still going to get the same stuff. Makes sense. Purpose of this note is to provide elementary proof of Minimax theorem that is accessible to undergraduate students. Minimax theorems date back to von Neumann in 1928, who established the first Minimax theorem in the special case that f of xy is equal to x transposed a times y, and xy are the spaces of probability vectors in Rd and Rk respectively. Okay. Initial setting arose in two-player zero-sum games. Since then, many extensions, two more general functions, f of xy, have been given. See 3 and references therein. Minimax theorems have found powerful applications in primal dual optimization. One way to think about the difference between the two sides of one is in terms of two-player games, where the first player is choosing x to maximize the function while the second is choosing y to minimize the function. When the supremum is on the outside, like on the left-hand side of 1, this amounts to the second player getting to observe the first player's choice x before making their choice y. Confers an advantage to second player. Vice versa, when the infimum is on the outside, like on the right-hand side of 1, the first player gets to observe the second player's choice y before making their choice of x, which confers an advantage to the first player. Thus, we always expect to see an inequality, which is verified in the following result. Okay, let x belong to that, y belong to that, and f be this, then supremum of infimum of f of xy is less than or equal to the infimum of the supremum of f of xy. Okay, so proof. For any x0 and x, we have the following. Okay, yeah, makes sense, right? Because x sub 0 for any x sub 0 is going to then be less than finding the supremum of big X. By taking supremum over x0, this gives... Right, so let's rewrite that maybe. Hang on. Okay. It said let X be a subset of the reals with dimension D, Y be the subset of reals with dimension K, F is defined as X cross Y going to reals. Just output. Okay, so we want the supremum of the infimum of f of xy to be less than or equal to the infimum of the supremum of f of xy, where supremum is taken as x vector in x, infimum is given as the y vector within y, right? So he said that if we choose any x0 belonging to x, therefore, nope, the infimum of f of x vector, y vector, y vector belonging to big Y is going to be less than or equal to f x0 there. It's less than or equal to the infimum of the supremum of any given vectors. Right, I'd say this is a pretty obvious result. And then this says that if we want to look specifically at nope. Oh no, right. This one is x sub 0 is going to have to be, by definition, less than the infimum of the supremum of f of all x sub y, where the supremum is chosen on as x vector on x, infimum is chosen as y vector on y, and then this is also less than or equal to the exact same words that we had above. Right, so if we just took all this stuff and said, look, this is going to be just color green for the sake of argument. This one here is the green one that we're working with. Right, this is saying that since f of x0 comma y is going to be less than or equal to f of x max y, like that. Like, I mean, we don't necessarily say that specifically, but I mean, there's a better way to say it. It's right there. Right, since f of x0y is going to be less than or equal to the supremum of f of all xy, supremum of x's on the set x, then we're going to have that the infimum of both sides is going to not change anything. So that relationship will still hold. Then it turns out that, oh, look at that, these are equivalent to each other. Congruent. And they're literally equivalent because they're the same words and symbols. Why? ¿Por qué? There we go. So in the paper, obviously this is sufficient. And in order to prove minimax, it is sufficient to show the opposite inequality. That the infimum of the supremum of f is less than or equal to the supremum of the infimum of f. But the problem is that this is more difficult to prove and does not always hold. Interesting. So if x has binary choice and y has continuous choice, both are -1, 1, but again, -1, 1 as a set is two different choices, like a binary choice, and bracket -1 to 1 is a continuous choice, and f of xy is equal to xy. Right, okay, so the max of the min of f is going to be the max of the min of y is -1, which yields a -1 overall for f of xy. But then the min of the max of f is equivalent to choosing the min of that would be the max of f, or the max of the set x, which should be 1. Hey, Zach. Yeah, I've got a question on this one. How do they get this part right here? Guess. Hang on. Oh. Tricky. Okay, so this is the choice of y that yields the minimum f value, and the choice in x that yields the maximum f value. Okay. I was thinking, oh, we just choose the minimum of the y's and the maximum of the x's, and there's only one result. No, not how that works. Right, so that makes sense here, in that our max of min yields an overall -1 possibility for the minimum of f. Yeah, right. Because if x is a binary choice, then that means that it can either go one way or the other, and that's it. That probably tipped you off there, right? X is the set -1 or 1, not a convex set. I'm not sure that I necessarily agree with this sentiment, even though, like, I know this person knows way more than I do. So, you may have to explain this one to me, Zach. E2I 2I pi. 4i squared pi? Negative 4 pi? It's backwards, isn't it? Any particular reason, Zach, why the author chose to switch infimum supremum here to max and min here? Apart from the fact that we're using Minimax theorems. Yeah, I mean, that's closed and bounded sets. Okay. Okay, so this was the first example that they gave, right? Can be. I mean, min-max is used in game theory a lot. So this is what he said. So we're using the supremum of f of x. We're trying to find the maximum value for f of x when x is either 1 or negative 1. Oh, they're not vectors. That's why they were using... Right, so they're just using single values. There we go. Okay, I get that part at least. Okay, so we're choosing the x value that's going to yield us the best, or the maximum f value. Yeah. So I don't necessarily agree. I mean, that could just be the point, right? It's causing us some problems because it's slightly paradoxical. So for -1 to 1, x is going to be a binary choice, y is going to be continuous. Definitely does not work this way, but okay. So the choice is that either we can go this way or we can go this way. And yes, it's supposed to be a function and all that, but just ignore it for the moment. So if we're taking the supremum of x, then we are choosing to ignore the bottom section entirely. Which means that we'll always get the maximum possible value. Coffee but black. Cheers. So it's saying that we're always just going to choose the highest value here no matter what we do. So in this case, this does mean that xy is going to be equal to the absolute value of y. Because here we have x equals -1, y is equal to, it's like any values that are from -1 to 0 belongs to, I guess. Whereas on this side, x is equal to +1, and y is going to be chosen from 0 to 1. Branches. Okay. So then in that particular case, then taking the infimum is going to say, now we want the bottom one here. I think I was only looking at this as like, the two possible choices, where we either have the point at 1, 1 or the point at -1, 1. And again, looking at like, we're trying to choose the lowest y value rather than the lowest function value. Okay. I think I get it. Maybe I don't get it. Okay, so did he skip a step here, realistically, and say, like, we're going to do the max of just -1, because I could yell about this. I could say, look, the maximum of f is going to be +1, not absolute value of y. I still don't like it. So, this is my problem. What I'm seeing here is that we are saying that the minimum value in terms of y for f of xy is going to become just a single value. But the maximum of f through x is going to be a continuous value. Now, I understand that that's because we're choosing a single x here, and we're choosing from a continuum of y's here. But I guess my problem is, why isn't this one choosing from a sideways absolute value, which is no longer f of xy, but rather the absolute value of x? And if you do that, the maximum function value that you can get is 1. Anyway. Minimax and saddle points. Introduce some notation. Say that x star is an outer max if of f if the supremum on the left-hand side is attained at x star. Likewise, y star is going to be an outer min. The infimum on the right, if the infimum on the right-hand side is attained at y star. We also define the notion of saddle point. Pair x star y star is called a saddle point if f of xy star is less than or equal to f of x star y star is less than or equal to f of x star y for all possible x and y. Outer maximum y is giving us a minimum.
You know the drill. End of series, credits roll, the next TV extra begins. But how can you move on when everyone's still talking about it? Pshyk has captivated critics. It's a romance scam thriller where a writer discovers her
Okay.
is hiding dark secrets. Digital spy calls.
So we're talking about two-dimensional objects, effectively.
Every kind of award. credits. Others get everyone talking. Stream
Right,
Fake,
so
now on ITVX.
wait,
Different, don't they?
X is supreme.
Home for a Christmas party.
So
Few people in the carriage, and someone's making others uneasy.
this says that we have
Someone isn't sitting right.
X star here.
Or speed. Just text 6116 and it goes straight.
We have
They'll get your message instantly.
Y star down here.
Text can protect you and the people around you. It's simple.
X star, Y star is there.
To remember, text 6116 discreet help and save the number for your next journey.
Right, so X star is maximized at this particular value, or sorry, the function is maximized at X star. So that means it'll go something to the effect of this. Doesn't have to, but you know. Whereas Y star is minimized. Nope. Function is minimized at Y star. So that's going to go this way. Effectively. Something like that. Right. So f is going to be maximized along y equals... No, that's backwards. Okay, so both of those things happening at the same time is really the important bit about that. Okay, proposition 3, let f be defined, again, same way there, belongs to the reals. If f has a saddle point at x star, y star, then 1 holds and x star is an outer max, while y star is an outer min. Conversely, if 1 holds, then it must be vice versa. 1 is, right, supremum of infimum of f is equal to infimum of supremum of f with the same x's and y's discussed. Okay. Yeah. Makes sense that, again, 4 holds only if this is a saddle point specifically. Oh. Hope everybody had a good weekend. Went to decorate Christmas cookies on Sunday. A whole bunch of friends were over, or a whole bunch of this person's friends were over. She was like, please bring your children. We have a lot. Okay. Okay, now give our main result. Proof of Mikaido's argument with some modifications. Theorem 4, let it be convex compact sets with non-empty interiors. X cross y, function f is continuous, and assume that x maps to f of xy is concave for all y's, and y maps onto f of xy is convex for all x. Then f has a saddle point, so let us define to start the proof, right? Phi of xy is the double integral of f of uy minus f of xv, parentheses squared. What's that plus doing there? I don't know what that one is. Oh, a plus equals max of a0. Okay. Since f is continuous on compact sets, so is phi. Therefore, phi must attain minimum point at x star y star. Proof is completed by showing that phi of x star y star equals 0, which we obtain from x star y star is a saddle point. Take the variation of phi that remains inside the convex domain for any t between 0 and 1. Take xy in x cross y, use convexity concavity of f to obtain phi of x star y star is less than or equal to phi of this is arXiv. November 25th of this year. In fact, right? That's December. Oh. Recent. It was recent. It's been moved down. Oy. Yeah, no. That's fair. So if we just... Yeah. It's not letting me. It's not letting me go back any further. Okay, well, whatever. X star plus t times x minus x star, comma, y star plus t times y minus y star. Okay, so this is interesting to me here. The fact that we appear to be saying that this particular function is linear in t. So we could take this 1 minus t term as on the inside of f and just filter it out. Was there anything we had to say, like, f is, it's just x cross y. Right, so it's not a particular function, particular type of function or anything like that. Example 1 does use it as specifically x times y, but that is not what they're doing here. Not explicitly, but so that, I think, is going to be my next question there. Is that we're seeing multiple locations where we have like f of u 1 minus t v star, or whatever, is equal to 1 minus t times f of u v star. Now, is this a function of it being a linear operator in T? Or is it something else? Okay. Rearrange the above to get this. Divide by t greater than 0. Take the limit as t goes to 0 from the positive. Use that for all a, b, and r, yielding the following. I'm going to have to take his word for it on this. H is skew symmetric. If we swap our x and our if we swap our inputs as groups, then it is negative on the outside. Okay. Well, guess I can see why this is in arXiv, right? It does get fairly involved as we get into it. I'm not going to be able to properly understand it, but nonetheless, he is proving that doing the commutativity of the infimum and supremum operators is going to hold under these different conditions. So it's not just minimax working for like super easy stuff. We also include the saddle point. We also include convex and compact, non-interior, and f is saying that y is unbounded. So if y is unbounded and we're looking for the infimum of y, then it's not too bad, because there will be a infimum value somewhere. Okay. Ads are about to start. I recommend getting up and stretching and doing all that good stuff, and we'll be back in 3 minutes. So thank you everybody for coming, and see you in a few. So... No, I guess that'll be enough. I'm looking at yeah, I'm trying to look at a couple of things that are in here, and I'm just not getting. Sorry, not even the paper. I'm trying to look at a couple of things that are in the rewards section to be able to throw some channel rewards on here. Like, I thought you could add like a audio thing. I'm not seeing any good ones on here. So if I add a custom reward. Okay, so if I add a custom reward, there isn't an option to add a sound. I can go to Blurb and build something from a sound. Might be the way to do it. Now, well. Oops. Yeah, so we're not getting anywhere on this one. Can sort of understand some of it, but again, here it's just mostly looking at, like, now we're able to prove Minimax, the Minimax Theorem using more cases. So here we're not just sitting on Minimax Theorem being applicable through only the only the supremum of infimum of f. Now he's expanding it to go backwards. Infimum of supremum of f is less than or equal to the supremum of infimum of f, given again supremum on x and infimum on y. So he was able to define it as if we have a saddle point of f, then it becomes provable. If we have convex-convex sets, then this has a saddle point, and therefore we can use integrals to prove that this works. If one of them ends up being unbounded, then we can end up making this work also. So, what's this? And again, this will have a saddle point on x cross r to the kth dimension of r. Okay. Yeah, all of these things end up being equal to each other. Okay. Cut that one. Linear geometry, flats, ranks, regularity, parallelity. Linear geometry describes geometric properties that depend on fundamental notion of a line. In this paper, we survey basic notions and results of linear geometry that depend on flat hulls. Flats exchange rank, regularity, modularity, and parallelity. I don't think I've ever actually heard that word before. So the fact that I said it in one, not too bad. Yeah. Okay, lots of definitions. Hey, Terry Tao. Okay. Jeez. When do we get beyond? You know what? There are thera splashed throughout as well. Is it just 21 pages of... Oh my goodness. Okay, so like, this is... Okay, so similar to, I guess, linearity. This is a, like, new sort of extension. First part of a series of surveys in linear geometry, area of geometry studying geometric properties that depend on lines only. Linear geometry has been developed by many mathematicians since times of antiquity. Yeah, well. It was formed as a separate area of geometry in the XXth century. Hey guys, you you might have forgotten a number there. Present main ideas and results of linear geometry using Bourbaki approach of mathematics which studies mathematical structures. Fundamental mathematical structure of linear geometry is that of a liner. Liner is a set whose elements are called points, endowed with a family L of subsets X called lines. Any distinct points belong to a unique line. Every line contains at least two distinct points. Family of lines L is called a line structure of liner X. Seemingly poor geometric structure allows us to develop rich geometric theory full of fascinating theorems and intriguing open problems. A self-contained presentation of this theory can be found in Book 1, from the first author, Taras Banakh. Ivan Hetman, Alex Ravsky, and Vlad Pshyk are also authors, or co-authors of this paper. Linear Geometry and Algebra, reprint 2025. Okay. Flat sets in liners. Subset A of liner X is called a flat if for any distinct points x, y. The unique line xy containing the points x, y, and a is contained in the set A. Okay, the size of A being less than or equal to 1 will be flat. So if you have 1 or 0 objects, they are also flat. But subset A is flat if for distinct points, any two distinct points in A, the unique line xy containing the points xy is contained in the set A. Grr. This is probably obvious, but okay. So, for instance, a liner cannot contain collinear points, like 3 collinear points, is what I'm understanding from this. Because distinct points must belong to a unique line. So, if you have 3 points that are along the same line in space, then you have 1, 2, 3 distinct point pairs that all create the same line in space. So I don't think that that's allowed in the liner. And anybody else who might be interested in this, yeah, let me copy this over. That's the one we're doing right now. Okay. So I think this is where we're going with this, is that A will not form a liner because X, Y, Y, Z, and XZ do not form unique lines. Whereas or at least this is my understanding. It is probably a terrible understanding. It may not even be true, but you know what? We're trying. Okay, every line contains at least 2 distinct points. So okay. Okay, technically they're X's, not A's, but whatever, it's fine. Like I said, I think this is where this is going. Every line contains at least 2 distinct points, which does mean that literally just x prime, y prime is a line. It's just 2 individual points. And those lines are not, or those points are not necessarily going to be connected through any intermediate points. Okay, so subset A of liner X is called flat if for any distinct points x, y, the unique line x, y containing the points x, comma, y is contained in the set A. Uniqueness of a line passing through 2 distinct points of a liner implies that every line in a liner is a flat set. Right, because we can't have any intermediate or outside points on that line which are also in the liner set. Doesn't work. For subset A of liner X, the smallest flat set containing A is called the flat hull of A and denoted by A bar. Flat hull of the empty set is empty. Fair. Flat hull of a singleton is that singleton, and the flat hull of any doubleton is the line x, y passing through the points x, comma, y. Okay. And then a flat hull of the triplet okay. So it okay. Yeah. for a subset of this. Right. So if it's a proper subset, then it's any flat hull is going to be equal to either the empty set, each singleton, or each doubleton. Could be. Right, so if we had like alpha, beta, gamma, delta, right, then x is going to be equal to alpha, beta, gamma, delta. Chi. Why would you do that? So A is going to be like alpha, gamma, delta, just for example. The flat hull is the minimum flat set, smallest flat set containing A. Distinct points x, y. A unique line containing the points x and y is contained. Megalomorph, we are getting confused, so. Right now we are currently working on a little bit of the definition of linear geometry, which is apparently a newish thing. By Banakh, Hetman, Ravsky, and Pshyk. So link just above there in the chat, and feel free to correct me on this. You and Zach have much more useful experience in trying to figure out new stuff. So, my understanding so far. A liner is a set X whose elements are called points, endowed with a family L of subsets X, of subsets of X called lines, which satisfy two axioms. L1, any distinct points belong to a unique line, and L2, every line contains at least two distinct points. So, it seems to me that L1 is implying that each of the unique lines that we find can only carry a maximum of 2 points which belong to set X. It can have an infinite number of other points, but they do not belong to set X. due to the fact that distinct points must belong to a unique line. Now, maybe I'm thinking too geometrically about this, and like, you know, I'm thinking too two-dimensionally, and maybe there's some other definition by which this makes different sense, and I just don't know it. And then every line contains at least two distinct points. It doesn't say that this necessarily belongs to X either, but again, I could be mistaken on that. Okay, so we're not going to curve space or anything like that. It's just that the line has to connect them. Okay, no, that's fair. Okay, so coming back here. So this does not necessarily mean that, for instance, collinear points x, y, z cannot be in X. I think my problem was here. Yeah. Fair enough. Yeah, so my issue was X, Y, Y, Z, and Z, X, Z do not create unique lines in terms of like two space, but you know, Euclidean geometry and all that, but that doesn't necessarily mean anything. This is even more general. Okay, yeah. Okay. Yeah, I don't think I've really done that kind of abstract geometry. Right. I didn't know if I was just getting hung up on the word unique. So they are all on the same line. And they form the same line. So therefore it doesn't make a unique line? Question mark? Finite geometries. Probably not really. Like, I did abstract algebra at the senior level, but I did not understand it anywhere near as much as I needed to, mostly because the guy who taught us got his PhD, quote, in the 40s, and he basically made up his entirely own language to do things. And so I was just like, I don't really understand where you're going with this, because, like, I know the stuff from sophomore linear algebra pretty well, and you're talking about all sorts of new things, which aren't really new things, but it's using a completely different language, so, like, I'm not correlating the two. And he was just kind of like, well, it's all the same stuff. Like, we're just trying to generalize the structures. And I'm like, but... So that might be a hang-up. Hey, Stookie. No, we moved past that paper because I was not here you go, there's the other one. That's the one on Minimax Theorem. We were looking at linear geometry by Banakh, Hetman, Ravsky, and Pshyk. Oh, I'm sorry. Definitely rest that voice. So, like, generally, like, projective planes are going to be, and definitely, please just tell me no if I'm wrong, but you have some sort of input that is going to have essentially an output function or what have you on this plane, and then essentially this is going to act like a lens. And do something to the other side. I don't even know. Like, it could very well do something like this. Question mark. I was just looking at the history and overview folder from math, and trying to figure out if I could understand anything. I was mostly looking at different teaching styles or something like that. So this being, Mondays being my math education night. That would be the idea, is that we kind of want to look at different teaching methods and seeing if there's anything there. We have popped into Mathematics Education Research Journal from Springer, which has a lot of people who are Deutsche Sprecher, I suppose, would be the most accurate word. But it's all in English. It's just that, like, all of the people who submit stuff are, like, in one of the Germanic language countries or something, like, I don't even know. Got a set X of points and a collection of subsets of X, which we call lines, given XY in X, there is exactly one line that contains both X and Y. But there are many different ways we could define what a line is. Yeah. For each individual pair, it is a unique line. I gotcha. Yep. That makes complete sense. Right. even if between the is not. Right, doesn't matter between the pairs if the line is not unique. Each individual pair produces one unique line. Gotcha. Okay, cool. But again, like you said, it doesn't necessarily have any relevance or relationship to lines in terms of, like, geometry. I get it. Yeah, okay. So, not necessarily what we're actually talking about, but all cool stuff. Yep. Last week we also were working a little bit on Exponential Idle, which is a fun little game if anybody's interested in that one. So I've been working on this Riemann zeta function, which basically you wait until the theory that you're working on, or you try to get the maximum growth in the scoring variable that you can. So there's like a whole bunch of tools online that help you try and maximize your scoring variable, which most times is rho. Man. Okay. So if we're looking at this, subset A of liner X is called flat if for any distinct points X, Y is in A, the unique line X, Y containing the points X, Y in A is contained within the set A. So what is this including or excluding compared to what we were just talking about? Two points in the plane, the line through those points is contained in the plane, true. Is it only flat if all of those subsets in 3 space are in that one plane? Oh, this is going to be a long section. Alright, so the subset is flat if it is then collinear with the defining points x, y. And those points are in A. Also in A. Right, and I've got the next part, right? If you have 0 items in A, or if you have 1 item in A, it's by definition flat. Or we have to include that because it has fewer than 2. You may lose patience with me, and that's perfectly fine. Every line in a liner distinct points belong to a unique line. Fine. Every line contains at least 2 distinct points.
You love listening to your favorite artists, and we love listening to you. So let's talk. Click now to take part in our short survey, and you could win a month of gloriously uninterrupted music with Spotify Premium. That means you can enjoy all your favorite artists ad-free.
Good family of liners is as follows. Let X be a vector set. Let L consist of 2-dimensional subspaces. Line through XY span of XY. Any subspace would be vector subspace would be flat. Vector space would be flat. Let X be a vector space. There we go. So if we've got amazing that I actually hit that on the first try. Right, so if we're doing R3, it's probably a terrible way to do this, but nonetheless. Mm-hmm. Yep. So this is going to be the plane that specifically contains those two vectors. You don't need to apologize. I think I was also asking that a bit earlier, in that not, x and 2x, but if xy was along a line, then if we pick a third point anywhere else, then anywhere else along that line, then the collinearity of those particular 3 points, well, I was wrong in that case, but nonetheless. Oh, okay, because their vectors are collinear, essentially. Collinear with the origin. Probably shouldn't think of it as being the origin, but nonetheless. Every line contains at least 2 distinct points. So, the way that I'm getting this at the moment is like a liner could be all of 3 space, and then a flat is going to be any particular plane that contains 2 particular points, whatever those points might be. And specifically looking at I don't know if we have to look at it explicitly. Regular 3-space with the usual lines, yeah. Could fix it by quotienting and going to projective space, please. Good times. Oops, sorry. Okay. I'll be right back. Ads are going to run anyway, so we shall return. Be back in 3 minutes. Thank you, everybody, for coming, and see you in just a couple.
You love listening to your favorite artists, and we love listening to you. So let's talk. Click now to take part in our short survey, and you could win a month of gloriously uninterrupted music with Spotify Premium. That means you can enjoy all your favorite artists ad-free. Sound good? Then all you need to do is hit the banner now for your chance to win.
Hey everybody, it's Michael Bublé, and it is definitely beginning to look a lot like Christmas. Listen to Top Supply 100 Greatest Christmas Songs Ever playlist to get in the holiday spirit. Tap to listen, Spotify.
Okay, we're back. Ended up pulling the cord out of my desk, just the phone plug. At some point I was like laying on the floor over there, so I wanted to have a bit of length on it. Okay. So. Yeah. I mean, we've got like a 2-meter one downstairs, but nonetheless. I don't need that here because most of the time I'm feeding it back through the hole in the desk, and then it kicks back up and around, plugs into my phone, and then when I unplug it, I hook it over the headset hook that's over on the right-hand side. Okay. Unique line containing XY. No, the unique line XY containing the points X, Y is contained in the set A. So again, pick any particular distinct points. In whatever subset it is. So in standard 3 space, a flat does not necessarily need to be a plane, right? As far as I'm concerned, in standard, like if liner X is R3, it seems that the subset A could be still R3 or any subspace thereof, because the 2 points that you create that are in A are going to create a unique line, and as long as the whole line is in A, okay, A point, a line, a plane, or all of R3 is a flat subset of R3. Thank you. Yes. Right. And as soon as you start creating a line, you have to include the whole line. Because every point along that line would need to be in A. And as soon as you start creating a plane, in theory. Okay. Yeah, and every... And the empty set. Yes, yes, right. Right, and then... Yeah, and then the second you create a go coplanar from just a line, then you need to include the whole plane, because now you've also gotten the span of the two vectors that create the 3 points, most likely coming from the origin, but not necessarily in theory. Does it have to include the origin? Seems like no. But you'd have to have a third point in A that is non-collinear, I think. For a subset A of liner X, smallest flat set containing A is called the flat hull. Parameterized by a linear. Okay, that's fair. Yep. Okay. I think it kind of breaks down on a continuous function somewhat, but smallest flat set containing A. So here you are excluding all what effectively is the multiples of the exact same value. So you're saying, like, okay, shrink it down to like a single value, essentially a unit circle, if you were thinking of a particular plane. And that would be your flat hull of a particular plane, would be just like pick a unit circle. That's probably not even correct.
I'm just calling to say
I don't think that's right. No. Okay, if you have three non-collinear points, then the flat hull is the plane containing those 3 points. Okay. Right, yes. I'll do that.
You know the drill. End of series, credits roll, the next ITVX show begins. But how can you move on when everyone's still talking about it? Pshyk has captivated critics. It's a romance scam thriller where a writer discovers her date is hiding dark secrets. Digital Spy calls it an aggravatingly addictive watch, while The Guardian says Asher Keddy deserves every kind of award. Some shows end at the credits. Others get everyone talking. Stream Pshyk, now on ITVX.
Do you enjoy discovering new artists on Spotify? Today, discover Santa Claus by clicking on
Right, so ABC, no matter what other points we have on plane P, it will create a flat hole P bar, ABC, or a flat hole P bar of flat space P. Might be a good exercise to prove that that flat hole is that plane. Oh no. Given that I don't have any projective geometry. So like... Yeah, no, that's fair. So, like, this is going to be sloppy, so yell at me. Any point, oh, nope. Any point, sure, why not? X belonging to P may be expressed as yeah, I was thinking something like this. Terrible form, as I said, but so we're effectively we effectively invoking span of B minus A and C minus A as our vectors there. Which, I mean, might be ugly as hell, but I'm pretty sure that's technically right. We have now a rum that I found. this weekend at a farmer's market. It was rather beautifully spiced. It almost has like no real sugar flavor to it, which is kind of nice. Y belongs to H because Y belongs to BC. X belongs to H because X belongs to AY. No matter which particular BC you're using, no matter which particular A you're using. Right, so we're using a flat hull ABC bar. Y has to belong to H, some new point. Okay.
When your kid's favorite toy starts to run out of battery power, no need to worry.
Right, it narrows it down.
Arriving today with Amazon Prime. Everyday essentials delivered fast. It's on Prime.
I'm Professor Huggington, and I like to hug.
Cut-off times and T's and C's apply. See product page when ordering.
Buddy's saying thank you for throwing his soggy ball again and again. Yes, Buddy, and again. But mostly, he wants to say thank you for his happy place. Oh, and for picking up his, you know.
Dogs trust know that if dogs could talk, they'd say thank you, just like Buddy. Help us give every dog a happy place. Dogs trust. A dog is for life.
Co-op members now get prices matched to Aldi. Hold on, no way. Okay then, so co-op members now get everyday essentials price matched to Aldi. Sign up and start saving. Co-op, owned by you, right by you. Wasn't expecting that.
Co-op member prices matched versus comparable selected products at Aldi GB. membership required. Co-op group food stores only. See co-op.co.uk/Aldi price match.
Come on. Any X in the plane must be in the whole of those 3 points. Okay. Okay. So I'll try and think of it in the way that you had it here. So if we have ABC as the flat hull, we could choose. We'd have to choose. You're saying let Y exist. Right, and this is just... No. Wait. Oh my God. Yeah, it is 2Ls. So, again, try not to look at this. Let Y exist collinear to BC, so therefore Y is going to belong to the convex hull. Damn it! To the flat hull. Jeez. Then... let X exist collinear to, it doesn't really matter. Well, to A and either B or C. It doesn't really matter which, but just pick one, right? Man, I'm dragging my stylus all over this thing. I missed with both of them. That's awesome. So like X1 there, X2 there. It doesn't really matter where it is. It's just a matter of bookkeeping in terms of like, oh, pick an option. Or I suppose X3 down below B. And since x, whatever it is, belongs to a b, x must belong to the flat hull. May not be exactly what you're going for there, but AX, BC will intersect somewhere unless they're parallel. AX, BC. True. And Y is that particular point of intersect. Okay. So we go. Ta-da! I guess, am I going backwards then? Am I trying to... You fixed A, B, and C. Oh, because you can shift. Right. Okay. You can say now, instead of worrying about AB or AC, we're specifically talking about A to Y. And X must be somewhere along there. Or we're defining X as being along that line, and therefore it must be in the I keep wanting to say convex hull. There is no convex hull here. It is flat. Flat hull. Oh, man. It's A and not B or C. It's A and Y. Okay. God, what a flat hole. Well, I also play Elite Dangerous, so like flat hole has a very different meaning. Alright, flat hull of empty set is empty. That's fair. Right, no, we already discussed this a little bit. Right, flat hull of a singleton is the singleton, flat hull of any doubleton is the line, x, y passing through those points. Alright, for any subset A of letter X, flat hull A bar is equal to the union of all sets defined by the recursive formula, I assume. A0 is defined as A and A sub n plus 1. Oh, A. And A sub n plus 1 is the union of all sets before it for some new n in omega. Proposition 2.3 implies the following description of a flat hull's inliners. For any set A inliner X, flat hull is going to be the union of F, which is in A's less than omega. So all previous sets that we have been talking about all of their flat hulls. It's the union of all their flat hull sets. Okay. A sub n plus 1 is going to be the union of all lines that we could possibly make from all points in all previous sets. I think that's what I'm getting. That's building quite a lot. Family of all finite sets of set A. For set X, we denote X bar by cardinality of X. Okay. Rank, double bar, of subset A of liner X is the smallest cardinality B of a subset B within X whose flat hull B bar contains the set A. Rank is monotone in the sense that A double bar is less than B double bar, or equal to. For any sets, A being an improper subset of B in a liner. Flat subset rank 3 in a liner is called a plane. Okay. Subset A of liner X is called a hyperplane if A is not equal to X. If X is a flat set, such that A union all X elements is equal to the X set. For all possible X's that are not in A but are in X. A is a hyperplane. A is a hyperplane if A is not the same as X, but A union with all of the missing elements is just going to be equal to X. Missing elements from X. So it has to be a Okay, so hyperplane in X is going to be something that if you just add the missing elements from X into A, you get X back. So there can be nothing that is non-coplanar. The only flat set that properly contains it is the whole space itself. Right. So there are no elements of A that are outside of X at all. Every subset A of a liner XL carries induced line structure. L arrow A is defined as L intersect A. L are the sub lines within the family of lines intersected with the cardinality of L intersect A greater than or equal to 2. X is the entire universe. Okay. I guess. Yeah, I guess I just found it weird. If that doesn't seem like a definition, that seems like a tautology. That if you take all of the elements in a subset of a larger space and then say, what are we missing that exist from the larger space, and fill in all those holes, then by definition it has to be said space. Like, it has to be the superspace. Like, I think that's just a definition of superspace. DickDuck, good evening and welcome, and hi everybody from DickDuck613's chat. My name is Obi-Wan Pez. This is N-Simplex Pachinko. We are doing some trawling of the archive. We got ducked. Nice. Hope you all had an awesome stream. I saw you hopped on earlier. And anybody who does not know DickDuck613, please go and check them out. So we're yeah, like I said, we're trawling the archive, looking at the definition of yep. I could go to the top, but you know. Yeah, linear. I was only on page 2. Linear Geometry by Banakh, Hetman, Ravsky, and Pshyk. So, we are, I don't have projective geometry or, like, you know, any real mathematics above, like, linear algebra at the senior level. So, talking about planes and subplanes and all sorts of stuff is kind of fun, but at the same time, I don't really know that I necessarily, classic math mood, yeah. Ow. And we're having a little bit of rum tonight from a local vendor. I believe they're called AB, which is a company from, like, 2 guys who started trying to make rum during COVID. And the guy who was at the tent was giving out free samples and telling everybody their story. So it was kind of cool. Another examples of liners, right? Okay, spherical geometry. X is the points on the unit sphere. Lines are great circles. Yeah, so we're following a unique definition of pick 2 points, x, y, and that great circle is going to be a unique line for those 2 points. True. There isn't a unique line through antipodal points. Fair. So we can exclude antipodal points just because we feel like it. So given any x, we cannot have, or given any a, we cannot have a star, which is the antipodal point of it. It's all right. Yeah. Or for that example, right? No, that doesn't quite work. I was thinking, oh, we could just pick like the top hemisphere, but then like the whole bottom hemisphere is excluded. True, yeah. So would my suggestion not work then? Because like lines would lines have to include the antipodal points? Half the equator as well. Okay. Oh, you punk. You want to restart my system? Go away. Sorry. Dangerously close to projected space. All right, fair. I mean, realistically, right? I need to learn all of the cool stuff. I had a colleague at my community college who specialized in differential geometry, and I was like, I really need to learn that. Never did. I mean, realistically, I should have like got none of the, well, yeah, all right. I should have gone like right down the line and gotten every single person's like understanding of whatever their master's PhDs were on, and like actually talk to them for a bit, but they would have found me annoying. Like, dude, I got work to do. Yeah, we have 21 pages to get through here. That's not happening tonight. No harm in rushing the process, yeah. The ones who found me especially annoying were the ones who were my supervisors at some point. Oh. Yeah, the there were a lot of issues. And then we moved to the UK, so like, oh man. Okay. Subset A of a liner XL carries the induced line structure. L arrow A is defined as L, okay, which is a particular line. Catch me if I'm wrong. Particular line intersected with A, the subset, and has a cardinality greater than or equal to 2. So 2 or more particular points within L intersect A that are also on the line L, which is within the family of lines fancy L. Every subset of a liner, yeah. Yeah, and we're not gonna get this. Okay. Particularly, I mean, there's some stuff, but those of you who have done projective geometry, especially Stuckey and Megalomorph, I suspect you're going to understand a lot more of this than I will. Oh, I also did one extra step on the... Where in the absolute crap? Okay. Just trying to figure out where PyCharm went. It just like disappeared out of my quick bar. Apparently, I don't even know what to do. Where did you go? No. What? Oh no, that's disgusting. Why would you do that? Ugh. Okay. Well, that's fun. So in Linux, when you sorry, in Linux, when you hit like the menu button at the bottom, it pops up your whole like, it's essentially like your tiled apps on your phone, right? It's got like a big square with 4 little ones inside of it. And I moved PyCharm into the science folder, as you do. And so it has been one of the 4 icons at the front to say, like, you know, come here to grab PyCharm. And I pulled up the tiled, you know, app menu, and in science there are 3 icons. Still, even now, there are only 3 icons. And I'm like, well, that's not right. So I was looking for, like, did it get kicked out and just thrown to, like, the second page or something? No. It's just not there. And so I clicked on the science app, or, like, the app folder, pulled it up, and it is one of the 5 apps that come up in the window. It just, when you minimize it down to the all of the app categories, all of the app folders, it just doesn't have a miniature version. That's weird. There are 4 lights. Nice. Positive reals with operations. Yep. A times B and A raised the log B forms a field with additive identity 1, multiplicative identity E. That's fun. right? If you're defining dot as your addition, and your multiplication as caret. Let's just mute this for a minute, and then let's pull this one up just for fun. So we were talking about Exponential Idle last week and on Wednesday, and we ended up with Lemma 6? Oh no, Lemma 7. Lemma 7 was the one we were talking about. We were looking for... Okay, so if we go to the actual... Let's go to the actual thing so we can read it out loud and not confuse everybody with my random ass. Don't know what you're talking about. Right, so... So we're trying to maximize the term called row dot, which is our change in, I mean row obviously, but the currency for this particular idle tapper. So it's an idle tapper game. You all know how idle tappers work. Updated by Snap. Cool. So the actual right, so row dot is equal to, no, don't do that. Row dot is equal to, this is Q over, nope, absolute value of E minus that one minus C1 over C2. Now I grant you none of this is going to make a lick of difference. This is not programmed into any bit of what is above. This is just for simplicity of everybody seeing what's going on. So for every second that goes by, no, that's not true either. Right. So this would be Q dot is equal to Q1 times Q2. Yes. Right. And then Q equals... Yep. Imagine this. Yeah, there we go. Q equals. Nope, I'm gonna have to do it after. Q plus Q dot. You go beyond addition, where multiplication is addition, and addition is log. Oh boy. Is it that one? No. Damn it. What's commenting? I don't even remember what commenting is in Python. This is terrible. Nope.
Hey, are you still asleep or already awake?
Anyway.
For sleeping or waking up, whether it's gentle light, soothing nature sounds, or your favorite station in the morning, we have what helps you start your day relaxed. Pure Movement, the premium radio and
Row plus row dot.
optional wireless charging. Wake up refreshed. Take a moment. Pure-audio.com. Joyful listening.
I mean, like, technically, but then... No, I think that's it. It's like... T don't. T dot is 0.1 seconds. So we'll do this nonsense pseudocode at the bottom. Right, but this is essentially what's going on. Is that you've got the option to purchase all of the Q1, Q2, C1, C2, where Q2, C2 are exponential with a factor of 2. So every single time they multiply by 2, their cost goes up a different exponential value. I'm not sure exactly what it is. Or potentially much worse. Q1, C1 increase pseudo-linearly. So there's some sort of floor function which is going to govern their behavior. I believe that they're essentially logarithmic eventually, but no, that can't be right. Because those dotted actually increase after a while. So they have a like delta Q1 and delta C1 of 1 until you get to a certain level at which it becomes 2. At which it becomes 3, 4, 5, and then it starts like increasing a little bit more, maybe quadratically or something like that, but it's still like floor increase. And it's much less than the exponential cost of all of these things. T dot, again, is just that it's going to tick once every 10th of a second, and so we're going to get 10 calculations per second, no matter what else is happening. Q dot is Q1 times Q2, and then our Q is going to be Q plus Q dot every time that there's a tick. So again, 10 times per second. Row dot is going to be this Q, whatever the Q value becomes in that tick, divided by the absolute value of E minus C1 over C2. So the goal, realistically, is to get C1 and C2 as close as possible to a ratio of E apart. So what we did in this case was to try to say, okay, our I is going to be 2j, whatever j is, and we create a while loop for j. J starts at 1, I then starts at 2. The best ratio is going to be 1, and then as long as I is less than 3j, again, we're trying to hone in on 2.7, 1828, 1828, 4590, 45, etc. if the absolute value of I over j is, minus e. I don't even need the exponential nonsense here. I just need e. As long as that difference is less than the absolute value difference of best to e, then this becomes our new best. So I over j, where I and j are the I best and j best. Then we print I best, j best, and what the best ratio is, and then iterate I and j. So when we actually do this, we get these pairs. So it starts with 2 over 1, and then 3 over 1 is a better ratio than 2 over 1. 5 over 2 is a better ratio than 3. 8 over 3 is a better ratio than 2.5. 11 over 4 is a better ratio than 2.666 repeated, etc. Theoretically repeated. And then we can keep going all the way through. I found that in the actual game, we can get out to 106 over 39 before we're going to reach the end of the amount that we can purchase. So if we try to go to 193, we're actually going to have more, or the 193 and the 71 for C1 and C2 respectively are going to cost us more than our goal is. So we're just done. And then we could find better rational approximations of E by going further down the list, just for fun. So Lemma 6 was very similar. However, in this case, our row dot was Q times C1 minus C2 over C3 minus C4, where C1 and C2 are increasing linearly, and C3, C4 are 2 to the 1 over E, and let me rephrase that. Level raised to the 1 over E, and level raised to the 1 over pi. So here we created the same stuff. But this time, now we've got it as, like, let's figure out what the levels are going to be for these weird values, and show me what the best difference? Yeah, show me what the best difference is between those two values. So this is going to be I raised to the 1 over E minus j raised to the 1 over pi. And I starts at 2. And if, I said if here, the 1 raised to the 1 over E is less than j raised to the 1 over pi, then we're going to iterate I until it becomes a larger value. Or else iterate j. And so it's just going to basically keep increasing one or the other until we reach a new best value. Which, it worked. We got here 2 over, or no, 2 raised to the 1 over E compared to 1 raised to the 1 over pi. Got us a decent value. That's going to be like the first thing that pops up. And then 2 and 2 for our bases. End up with a 0.0435. Then, this is where it gets weird. 4, 5 is going to get us a negative value, but it's still pretty significantly better than the other one. Since this is negative, we have to reverse the polarity, if you will, on C1 and C2, which are in the numerator. Basically, we shift all of our purchases from C1, so it's C1 minus 0, to now 0 minus C2 to flip it negative. And then once we reach 8, 11, it's positive again. And then 11.16, it's negative again for a few more here. And then we keep moving down and down and down. I think once we reach 39.69, we get this negative 0.00003444. That's as far as we're going to go with the purchasable values. Again, the purchase value of the next thing is further along than we can actually get. So trying to get up to 398 and 1011 is bonkers, and it doesn't produce an appreciable difference in like the value. It's not even like, I mean, it's a percentage, but like it's not a decent percentage. And then like 1.02 times 10 to the negative 5 is, you know, a factor of 3. So again, it's not like a huge appreciable difference. So even if we could purchase the rest of those, like there's no point. 39.69 is the best combination for this. Of course it's the best combination. Nice. So we're going to go through that and say like Lemma 6 gets us this stuff here. And again, we can create the best purchase right here. So if anybody's interested in Exponential Idle, it's a somewhat silly, you know, idle tapper game, but it does have some interesting little things that you can work with to try to optimize what route you can take with it. So it's a little bit of fun. We're going to come back on no, we're going to come back tomorrow. Allegedly. We have our 9 Souls night, which is going to be dominated, at least at the beginning, with trying to figure out how to beat the twins. And then we will be back on Wednesday, possibly Thursday. This week's a little bit different because on Friday we're flying to Morocco. So the family's going to take a trip out to somewhere warm and sunny so that we can soak in the vitamin D and have a little exposure to a different culture. So we'll go see how Marrakesh is. I think it should be really awesome. I hope you all have a wonderful evening, a wonderful rest of your day, week, whenever I see you again. And we'll be back tomorrow, like I said, doing 9 Souls. So a little bit of Tai Chi Kitty. So, see you all later. My name's Obi-Wan Pez. This is N Simplex Pachinko. Until next time.